Hi everyone, welcome back to my math channel online today. Today is a beautiful day, very sunshine day. However, it has a gentle breeze, so it's not too bad as we have 4 days of heat waves and we suffer from that a lot because most of the residents in our hometown, we don't have the air conditioning. Usually each year, it's only 1 or 2 days hot and the weather is not too bad. But this year it go up to 44 degrees, which is unbearable without air conditioning, right? So I'm glad that now everything go back to normal so we can function. So let me function and show you a new lesson today and review for you the Math 11 about the basic function. So today I will show you, review the basic sketching of trigonometric function. Also from here, usually we sketch the transformation of any function based on the basic one. And therefore I think that it's necessary to review for you about the basic sketching, even though a lot of you might know already about how to sketch those basic functions, but I still would like to repeat it just in case we need to go further and we connect to the new lesson about the transformation of these functions. So let me show you how to sketch the basic one. The first basic one is we call a y equals sine theta. Now, usually we base on the table, right? And then we plot the point and then we sketch the function. But however, this function is easy to divide it on the scale like this. And you also can relate it to the circle, right? Because the full circle, right, from here to here, let's say you go from this point and you go the full circle, it's 360 degrees, which is 2 pi, right? And then we divide it. And let's say we divide half of circle is pi. And then divide by half circle, here is pi over 2, which is 90 degrees. And down here is 3 pi over 2, which is 270 degrees. And back in here, 360 degrees, which is equivalent to 2 pi for the full circle. So let's pretend that we have the, let me close the door. So let's say we have the axis here, and we want to say from a 0 point here, right? We will select a certain distance represent a full circle 2 pi here. Let's say if I select this point as 2 pi, it means half of this point will be 1 pi. So I divide the distance here by half and I got pi, right? And here is 2 pi. Now on the other side will be the same, which is this is minus 2 pi, and this is minus pi. So these are the basic point we want to sketch. Also, on the y-axis, right, on the y-axis, you pick up a distance from 0 to here as 1 and from 0 to down here as minus 1. Now, the basic sine function, the maximum height of it alternates between 1 and minus 1, right? And it's a wave, right? The sinusoidal, we call it sinusoidal wave, right? So it's sinusoidal because it keep repeating, right? Like the wave keep repeating. So one full circle stop at 2 pi, but if we continue, it keep go another second full circle and third full circle and so on, right? So let's sketch one full circle here for the sine function. So the maximum will be on the top here and start from 0, right? Now, if we divide this 0 pi in half, this will be pi over 2. And if we divide between pi and 2 pi in half, this number will be 3 pi over 2. And of course, this side will be the same if we divide by half for each of this, right? So the sine function, actually, it go maximum, it start from 0 and go maximum to 1. And it cuts through the pi, right? So the way look like this. And it go through the pi and it go down at -1 here. And then it end up right here. And the other side will be the same like this. It will go here, cut through the -pi, go up to here as 1, and go through here. So this kind of sine function. And if we make it a little bit tricky, we can make it, instead of pointed, it should be like a smooth like shape like this, right? So this is the sine function. Now for the cosine function, you will do the same, right? You will pick up a certain, let's say you pick here at 2 pi, and you divide by half, you get 1 pi. And here, the same distance from here to here, so it's about here is -2 pi. And this is -pi. And you divide the pi into a half again. So this is pi over 2, right? And this is 3 pi over 2. And of course, this is the same except that minus, right, on the other side. So now for the cos, if the sine we start from 0, right, then the cos we will start from up top here, right? It's still a wave, right, a wave shape. However, we start, the cos we start up here, and we kind of cut through pi over 2. So we go like this. So we start here and we cut through here, and we go down here at the -1 level, right? And we go cut through the 3 pi over 2. So at here is the minimum level. Shape looks something like this, right? Here's the minimum. And then it go up and go up here. So this is one side way of the cos side. And on the other side, we do the same, which is cut through here. And it go here as minimum. And cut through this shape and ended up here. So that's another way on the other side, right? So this is the cosine, how you draw it, how you sketch it. And I think I might not didn't do it very good shape, but that's how it looked like. You see better. Okay, so that's how you draw the coach. So this is the sine and this is coach. Remember, this is the maximum point for the coach, right? Maximum point. And this is the minimum. And this is minimum for the sine. And this is maximum for the sine. So notice the maximum for the sine at pi over 2. For the cos, the maximum at 1. For the x-axis, the maximum at pi over 2. For the x-axis, the maximum of cos is at 0. 0 and 1. This is pi over 2 and 1, right? So notice that. So this is how you get the sine and the cos in the basic way. Now let me show you how to do tan as well, right? So again, we're going to pick up the tan as the 2 pi period, right? We'll divide this to get pi and divide half to get pi over 2. And this is 3 pi over 2. So this as well, 2 pi and minus, like this. So the tangent will have the two asymptotes at pi over 2 as the asymptote. And the reason it have an asymptote because at this point, the function does not exist. So at this pi over 2, the function does not exist. And that's why it have a asymptote go like this. And actually, the cycle of the asymptote is pi over 2 adding with n pi. So add another n pi, we have another asymptote at 3 pi over 2. So for the tangent, and the other side will be the same, which is minus pi and 3 pi over 2. So we have an asymptote at pi over 2, pi over 2, 3 pi over 2. Let me, I think I mark a little bit off. It's not quite even. So let me mark it again. So this is minus pi over 2. And this is pi minus pi. And this is minus 3 pi over 2. And minus 2 pi. So we have this one right here. Is the minus pi over 2 and pi over 2 as the asymptote for the tangent and minus 3 pi over 2, right? So the way you draw the tangent, you will say, and here is 1, down here is minus 1. So usually the asymptote, it means at the function getting very high in the positive way, right? Then the function shape according to the asymptote, but it will in the middle here go to number 1 like this, and it go to 0, and it go down here and in the middle at number 1, and it shape along with the asymptote like this. Right? So it have the shape like that. It goes through the 1 in the middle and 1 here at the middle on this side and go down like this way. Now this keep going the same thing. So then it will go to the 1. So if you draw a little bit line like this way, it will cut through this, right? So it will go this and go to here, go in the middle here and shape along with this line. Again, this one will shape along with the asymptote and cut through this point and go through this point and cut down here at the 1 level, right? This, and then shape along with the asymptote. So that's how the tangent look like. And the reason because at this point for pi over 2 and pi over 4, if you key in 10 of pi over 4, the answer will be 1, right? So it have a shape like that. Now for the cot theta, you have exactly the same. So we're going to mark 2 pi here and pi here, right? And half of this will be pi over 4, And down here is minus 2 pi, and half of it is pi, and half of it like this. So now you will have the same asymptote like this, except that the shift, the asymptote will be no longer. In here, the asymptote is pi over 2, right? But in the cot function, remember the cot theta equal 1 over 10 theta, right? So at the point where the 10 theta cut at the 0 axis, right? Cut at the 0 at this point and this point, right? We have 1 over 0. And 1 over 0, it means, so right here, the y is 0, right? So cot theta is 1 over 0 because 10 theta is 0 here, right? This point, which is pi and 0. At this point, we have an asymptote for the cot because when it's 1 over 0, the function doesn't exist. So now we know we have an asymptote right here, right, for the cot function. And at the pi as well, there will be another asymptote. And of course, at 2 pi as well, there will be another asymptote. So this one is similar. We have asymptote here. And the cot, because we have 1 divided by 10 theta. So when 10 theta are getting very high, which is 1 divided by a very big number, 100,000 or something, right? Then at that time, 1 divided by 100,000 will be 0.00. So when the 10 is got high, the cot is got slow. When the cos it got slow, the 10 is got high. It reverses like that, right? So therefore, at the asymptote, the cot function will look something like this. So this is the asymptote. So when it will opposite with this one, right? When this one go high, this one, the cot will be go very low. And when the 10 is low, the cot is getting high. So when the 10 here getting close to 0, right? The cot actually up somewhere here, right? Up somewhere here. Up here, right? Because when the function of 10 get close to 0, the cot go up like that, right? So that's why it has a shape reverse like that. So this is the shape of the cot function look like. It just reverse the other side, right? Because at 10 get close to 0, the cot 1 over 0 will go very big, high, infinity, right? And at 10 go up to high, the cot will go very low to 0. So that's why it have reverse shape like that, right? It have reverse shape like that. You can see that, right? Right here. So that's the idea. Okay. So now let me show you how to sketch the cosine function. So now I'm going to base on the sine. I'm going to sketch the second function. This is the fifth function. Let's say I'm going to sketch the cosecant theta. And how do we sketch the cosecant theta? Remember, 1 over sine theta equal cosecant theta. So again, it means that this function is the inverse function of sine theta, right? The inverse function. So when the function of sine go high, maximum, right? Then the cosecant theta will go the same 1 over 1 right here as 1, right? So at the same point. So at the same point at 1 here, the cosecant have this shape. However, because when this one get close to 0, the cosecant will go up this high, so it have a shape look like this. And when this go low to 0, this will go up like this, right? So based on the sine, we can sketch the cosecant. Actually, this is the shape, and this is the shape. Similar like that, right? When it go maximum 1/1, it's just 1 for cosecant function. And when it go low to 0, this one go up high like this. So as minimum function, the cosecant will go like this way, right? And that is supposed to be for the cosecant function. Okay. So now let's talk about what about the secant function? And that would be the sec y equals secant theta. Now, secant theta is the same like 1 over cos theta, right? Will be equal secant theta. So 1 over cos theta, the same shape. When it at maximum height, 1/1 is the same, right? And when it go up, this one go down. And when it go down, the other one go up. So this is the shape of secant theta. Same like this way. It will go this way. And at the minimum, it look like when it go up, this will go down. When this go up, this will go down. So that is the secant theta. So when this one is close to 0, this one go to infinity. And when this one keep going this way, then this one go up this way, right? It's opposite, right? This is down, this is up, this is down, this is up. So that is how you sketch the secant theta. Very much the shape like this. Just like cosecant theta, the inverse of sine and cosine. So these are the basic functions. I would like to show you how we sketch it. And my next video, I will show you the technique of how to sketch the transformation of these sinusoidal function. So I hope you enjoyed this video, and noting is good as practice. If you want to know how to sketch the trigonometric function, you have to actually use your pen and divide the scale like I show you, and actually sit down and draw it and sketch it. Then you will be able to learn how to sketch the shape, right? If you just watch the video and you don't practice on your own, it's useless. To be honest with you, you got to actually pick up the pen and do it on your own. So watching is one thing. After you know already, follow it and practice. So I hope you enjoyed this video, and bye, and see you in the next video. Thank you for watching. Bye for now.